Hi, this is Mr. Merrill, and we're going to look at another example with this universal gravitation dealing with multiple masses. So there's one like this on the UT, and we had worked one in class. This is a third one just for extra practice. I recommend before you continue on the video, try it for yourself, see how far you can get, and then when you get stuck, you can play the video and see where you got stuck at. Okay, so to begin the problem, it's asking the problem statement for just the magnitude of the net force. It's not spelled out, but we're looking for the magnitude of the net force, but I'll also show you how to find the magnitude of the acceleration. It's very easy if you have the one to find the other. And I'll also help you figure out how to find the direction. And we'll see that at the end of the problem. So we're going to do those three things. What you have to start out by doing this problem is thinking about the geometry. So it's nice in this problem they already lay it out on a grid. Each of these little tick marks represents a meter, and you can see where the position of the other two masses are. So we're going to think about the geometry. So we have the kind of the y and the x distances. Using Pythagorean theorem, we can find the separation between the 7 and the 5 kilogram mass. That's just the square root of this squared plus this squared, and you get 5.1 meters. I encourage you to check that yourself. And then between the 7 and 8, it's easy to see we have a 3, 4, 5 triangle. So that's that hypotenuse. That's going to be needed for putting into d squared. The other thing we're going to need to break down the force vectors later on in the problem is these kind of off-axis angles. So I found this angle here using tangent. You could have used any other trig function because you know all the sides. But I found it to be 11.31. And then I did the same thing down here, 53.13. So I take that information about the angles and I use it when I'm drawing my force diagram on the 7 kilogram mass. So again, we're looking at the forces at that center mass. So I don't have them labeled here just to keep it kind of neat, but the red arrows are representing the x components of these two forces, and the blue arrows are representing the y components of these two forces. So I want to think about breaking these forces down, and this is where the tedious part gets. So starting out with the upward left pointing force, the 7 on 5, it has a negative x component. It is opposite to the angle given, so we're using sine. And then you hopefully can see how this multiplication by the magnitude of this force is just according to Newton's law, which we have written up at the top there. So 7, 5, 5.1 meters per second. The y component is only changed by that trig function in front. It still has the same magnitude. And then we do the same thing for the other force vector that points down and to the right. And it's saying its x component is adjacent to the angle, its y component is opposite. Go ahead and feel free to pause there and make sure you see where all these numbers are coming into play, where they're coming from. So this is just copy and pasted from the previous slide. These are the components written exactly as they were in the previous slide. And what we want to do here is begin thinking about how these combine into kind of a net force and how that affects the acceleration. So Newton's second law tells us the sum of the forces, or the net force, equals the mass times the acceleration. So I'm getting these terms down here. I'm just looking at the x component, the two x components, and adding them together. You can see the mass, well, that's the mass of the system itself, the 7 kilogram mass. So putting that in here, you see a nice cancellation. Every single term has a 7 kilogram in the top, so that allows us to divide both sides by 7 kilograms and it cancels out. And then you have this kind of long multiplication, but you put it in your calculator, and again, go ahead and check it, make sure you can do these basic steps in your calculator. But I get an acceleration in the x direction of that. You should get something close. And I do the same thing in the y direction using the two y components. So the sine and the cosine over here in the y components. Again, we see the 7 kilograms cancel out, and again I find the magnitude of the acceleration in the y direction. So now the question is, why did I find these x and y accelerations? Well, there's other ways to solve this problem, but the reason I found the x and y acceleration because I knew if I had the x component of the acceleration shown in the red here in this vector that I've tried to draw, and the y component of this acceleration shown in the blue, that forms a right triangle where the hypotenuse is the magnitude of the acceleration. So again, I can do geometry here, squaring and taking the square root. I can find the magnitude of the acceleration. That's this number here, this 1.0816 times 10 to the negative 11 meters per second squared. And I can also find this angle. If the problem wanted you to indicate the direction in any way, this angle below the horizontal can be found using tangent. If you've forgotten, when you're using tangent, because we're just thinking about these components as sides of the triangle, I drop the negative on the y component. You'll notice if you don't drop that negative, you'll get kind of a weird answer, and you can go ahead and try that yourself. So once I have this magnitude of the acceleration, again, Newton's second law tells us how that's related to the net force. It's real easy. You just multiply by the mass, and that gives us the magnitude of the net force. So I think the difficulty of this problem is all the geometry involved, separating in your head, okay, when do I want to find a component, when do I want to find a magnitude, and kind of pulling that all together, because there's a lot of numbers and calculator manipulation where you can make a mistake. So make sure you work every single one of these sample problems. If you want more practice, you can email me and I can give that to you. But if you have any questions about this particular one, just let me know and I'll try to walk you through it in person. Alright, thanks.